Hello students, today we will discuss types of capacitor and grouping of capacitors in series and parallel. How the capacitor is constructed and what is capacitor? A capacitor is simply an arrangement of conductor in which without increasing the size of conductor its capacity gets increased. Okay, the net charge present on both the plates of capacitor remains equal to 0. Between the effective overlapped volume, energy gets stored in the form of electrostatic potential energy. Okay, so let's see types of capacitor. We will see parallel plate capacitor and spherical plate capacitor, then grouping of capacitors and important points about capacitor. Okay, we are talking for parallel plate capacitor. The figure shows a parallel plate capacitor. The second plate is connected to earth. The first plate is having surface charge density plus sigma. Here it is minus sigma. If here is charge plus Q, then here due to induction here is charge minus Q. Let us assume separation between plates of capacitor is D and capital A is what? Surface area of each plate of one side. Now dear student, between any 2 points at the plate of capacitor, just look at any point here. Electric field intensity is here sigma upon 2 epsilon 0 and sigma upon 2 epsilon 0. So between the plates of capacitor, electric field intensity everywhere is sigma upon epsilon 0. What is potential difference? The potential difference is sigma upon epsilon 0 into D. This is potential difference. So C is what? The capacity of capacitor is what? Charge given to any one plate divided by potential difference. Okay, so what is V? V is sigma D upon epsilon 0. And what is sigma? Sigma equal to charge upon area. So dear student, this is the capacitance of parallel plate capacitor. Okay, so this is the answer. C equal to epsilon 0 A upon D. You can see here this capacitance depends on the geometrical dimension as well as medium. Okay. A dielectric is an insulating medium. Suppose a dielectric material is filled between the plates of capacitor. The dielectric constant is epsilon r. So C medium equal to epsilon r into C air. This is the formula. And dear student, if a dielectric slab having thickness T is inserted between the plates of capacitor having dielectric constant epsilon r at any distance, then its capacitance is given as epsilon 0 A upon D minus T plus T upon epsilon r. Dear student, if the two plates of capacitor are connected by a thin conducting wire, then what will happen? Potential difference between plates become 0 and capacitance will become infinity. Okay, this is what thin conducting wire. This is the value of C. Okay. Now, dear students, we will be looking for spherical plate capacitor. These are concentric metallic shells having radius A and B respectively. Let us assume here we have given charge Q. Then what will happen? Due to induction, here minus Q charge will come. And since outer plate is earth, so the positive charge will go inside the net charge has become 0. Okay. So what we are doing, potential at the earth connected point is 0. Now dear student, let's calculate potential at point A as we calculated in electrostatics. Okay. So potential at point A is what? KQ upon A minus KQ upon B. So this is KQ, B minus A upon AB. This is potential at A, and potential at earth connected point is 0. So dear student, what is value of C? What is value of capacitance? C is what? Q upon VA minus VB. Charge given to any one plate divided by potential difference between plates. So what is the answer? Answer is 4 pi epsilon 0 AB upon B minus A. Dear student, this is the answer of the capacitance, okay, of spherical plate capacitor, okay. Now let's see some important points, that is series and parallel grouping of capacitor, okay. Now let's see grouping of capacitor. First see series grouping. Series grouping of capacitors. In the figure, the three capacitors have been shown connected in series and across which a battery of potential difference V is connected. Capacitance is C1, C2 and C3. Let us assume charge here is plus Q minus Q, plus Q minus Q, plus Q minus Q. Now we are applying KVL here. So what we are getting? V minus Q upon C1 minus Q upon C2 minus Q upon C3 equal to 0. And if equivalent capacitance is C equivalent, so this is the final equation, okay. So after equating these two equations, we are getting the result 1 upon C equivalent equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. This is the result in series circuit, okay. But dear student, if we talk about the potential difference between the plates of capacitor, so this is what? V1 equal to Q upon C1, V2 equal to Q upon C2 and V3 equal to Q upon C3. Okay, this is the potential difference across the plates of capacitor, okay. If we talk about energy, the energy stored between the plates of first capacitor is Q square upon 2 C1. Remember, U proportional 1 upon C in case of series combination. And work done by battery is what? This is charge supplied by battery into potential difference across battery. Okay, this is the work done by battery. Okay. So dear student, this is all about the series grouping. Okay, now let's see about the parallel grouping. Parallel grouping of capacitor. the important property in parallel grouping is what? Potential difference across the plates of capacitor remains same. Okay. Here three capacitors have been shown in parallel connection, across which a battery having potential difference V volt is connected. If charge Q is passing from here, the charge is dividing as Q1, Q2 and Q3. This is plus, this is minus, this is plus, plus and minus. Okay. Apply junction law, we get Q equal to Q1 plus Q2 plus Q3. Now, apply KVL. What we are getting here, capacitance is C1, C2 and C3. So, dear student, we are getting V minus Q1 upon C1 equal to 0. V minus Q2 upon C2 in middle branch equal to 0. In lower branch, V minus Q3 upon C3 equal to 0. If you substitute all these values, you will find C equivalent equal to what? C1 plus C2 plus C3. This is the value of C equivalent, okay? So in parallel grouping, equivalent capacitance remains more than the highest capacitance connected in the circuit, okay? If you talk about distribution of charge, this is directly proportional to the capacitance. If you talk about the energy stored, then energy stored is directly proportional to C because potential difference remains same, okay? And what about the work done by battery? This is charge supplied into potential difference, okay? This is all about the parallel grouping. Now we will see some important points for solving the problem in problem of capacitor. These are important points to remember, okay? For solving the problems of capacitor. If the capacitance of air capacitor is C, if you insert dielectric material between the plates of capacitor having dielectric constant C, then its capacitance will become C into epsilon R, okay? If this is capacitor and connected with battery, if you insert the dielectric or you do anything, but if battery is connected, okay, remember if battery is connected, then potential difference across the plates of capacitor will remain same. Potential difference will remain same. Remember, this is important property. For battery connected capacitor, potential difference between plates of capacitor will remain same. Dear student, now if battery is connected, what you are doing? You are inserting the dielectric, but battery is removed. If battery is removed, then what will happen? In isolated capacitor, remember the most important thing is charge will remain constant. Charge on the plate of capacitor will remain constant. Okay. So these are the important points to solve the problems in capacitor, okay? And the fourth important point is that work done by battery will be taken as positive if charge is supplied by battery into potential difference across battery, okay? And this is a general equation. This is initial potential is stored plus work done by battery equal to final energy stored plus heat loss. This is the calculation. This is the equation to calculate the heat loss, okay, when capacitors are connected. So all these points are very important to solve the problems of capacitor, okay. Now let's see some problems. In this problem, a parallel plate condenser has a capacitance 50 microfarad in air and 110 microfarad when immersed in an oil, okay. The dielectric constant K of the oil, directly you can write the dielectric constant is equal to what? Capacitance in liquid divided by capacitance in air. Cancel 0 and 0. Now this is 2.2. Okay, this is the dielectric constant, okay. So out of 4 options, the correct answer is option 4. Now, dear student, let's see. Find the equivalent capacitance between A and B. In the given figure, you can see this 2 microfarad and 2 microfarad is connected in series. Okay. So equivalent of 2 and 2 will become 1. And dear student, this 1 and 1 is connected in parallel. So again, it will become 2. Now 2 and 2 is connected in series. Then again, it will become 1. And dear student, 1 and 1 is connected in parallel. Then it will become 2. Okay. So answer to the question is option 2. So answer is option 2. This is the situation of balance between stone bridge. 5 capacitors of 10 microfarad capacitor each are connected to a DC potential of 100 volt. As shown in the adjoining figure, the equivalent capacitance between point A and B will be equal to. Dear student, because here potential at this point and this point will remain same, this 10 microfarad capacitor can be removed. So this 10 and 10 are in series, this 10 and 10 are also in series. So 10 and 10 equivalent means 5 microfarad, 10 and 10 equivalent means again 5 microfarad. 5 microfarad and 5 microfarad is connected in parallel. So it will become 10 microfarad. So dear student, the answer to the question is option 4. So in our case, answer 4 is the correct answer. Now, dear student, 2 dielectric slabs of constant K1 and K2 have been filled in between the plates of capacitor as shown below. What will be the capacitance of the capacitor? Now, always remember, when the dielectric material, when capacitor divided between the plates of capacitor, then capacitor formed remains in series. Okay. Whenever division of separation between plates of capacitor is done, dear student, whenever division of separation between plates of capacitor is done, capacitor formed always remains in series. And in series, I am telling you about the short trick. Otherwise, you can solve C1 and C2. Then you can write 1 upon C equivalent equal to 1 upon C1 plus 1 upon C2. But that will give you long result. Okay. If you solve here C1 is what? Epsilon 0 A upon D by 2. And if you solve C2 here, this is a what? Epsilon 0 K2 A upon D by 2. The final result is C1 C2 upon C1 plus C2. This is C equivalent. But I am telling you the short trick, okay? Whenever capacitor are connected in series, the dielectric constant is harmonic mean. So dear student, K equivalent is what? 2 K1 K2 upon K1 plus K2. So in this case, C equivalent will be what? Epsilon 0 A upon D into K equivalent, okay? So epsilon 0 A upon D into 2 K1 K2 upon K1 plus K2. In the option 4 is the correct answer, okay? Otherwise, you can solve the question by like this also, no problem. This we have already seen. Separation between the plates of a parallel plate capacitor is D and the area of each plate is A when a slab of material of dielectric constant K and thickness T is introduced between the plates, its capacitance become, let's see. Let us, this is T, this is X, then this is D minus T minus X. Here electric field is E1, here electric field is E2, here electric field is E3. So dear student, potential difference here is V1, here is V2, here is V3. V1 is what? E1 into D. And E1 is what? Sigma upon epsilon 0 into X. What is V2 here? E2. E2 is sigma upon epsilon 0 into K into T. And what is V3? Again sigma upon epsilon 0 into D minus T minus X. So what is potential difference? V equal to V1 plus V2 plus V3. Okay, so what is C? Charge given to a plate divided by potential difference. If you solve the equation, okay, you will find the relation epsilon 0 A upon D minus T 1 minus 1 upon K. So the option 3 will be the correct answer, okay. This capacitance do not depend on X, okay. Now, dear student, 5 capacitors, each of capacitance value C are connected as shown in figure. The ratio of capacitance between P and R and the capacitance between P and Q. First calculate between P and R. This is P and this is R. This C and C is in series, and this C are in series. So this is how much? This is C by 2. This is C by 2. And this is what? C by 3. Okay. So equivalent between P and R is how much? C by 2 plus C by 3. This is what? Because they are in parallel. 6, 3 plus 2C means this becomes 5C by 6. This is capacitance between P and R. Now, dear student, let's see between P and Q. Okay. C. This is C by 4 connected in series. This is P. This is C. This is Q. And this is C by 4. So, answer is C plus C by 4. This is 5C by 4. Okay. So, ratio is what? Ratio between P and R and C between P and Q. This is 5C by 6 divided by 5C upon 4. So answer is 2 upon 3. Okay. So the answer to the question is option 3. So dear student, option 3 is the correct answer. Now, an infinite number of identical capacitors, each of capacitance 1 microfarad are connected as in adjoining figure. Then the equivalent capacitance between A and B. Now you can see here 2 capacitor of 1 microfarad in series means 1 by 2. 4 capacitor means 1 by 4. 8 capacitor means 1 by 8. 16 capacitor means 1 by 16. So what is the answer? This is 1 microfarad. This is 1 by 2 microfarad. And this is 1 by 4 microfarad. And in a very similar way, infinite. Okay. In parallel combination, all capacitance will get add up 1 by 2 plus 1 by 4 plus 1 by 8 like this. So here this is forming GP, common ratio is 1 by 2. So answer is A upon 1 minus R. So answer is 2 microfarad. So answer of C equivalent is 2 microfarad. Okay. So dear student, here option 2 is the correct answer. Now let's talk about the RC circuit. Okay. Dear student, now in the next lecture we will be looking about the RC circuit. Okay, growth of current in the RC circuit. Thank you very much.